争取能到 World Final，然后我也会继续练习。
For me personally, it would be cool to be on the cutting edge of technology.
does progress in science and technology come from? From insights gained through practices, from sparks of discovery, from inspiration sparked by the clash of ideas, from elevation achieved through the fusion of different perspectives. In 1654, Pascal and Fermat opened the door to probability theory in their discussion on the problem of points. In 1687, Halley persuaded the hesitant Newton to write his great work, Mathematical Principles of Natural Philosophy. In 1736, Euler attempted to solve the puzzle of the 7 bridges of Königsberg, which led to the creation of graph theory. In the early 20th century, Einstein and Bohr collaborated and completed to develop the theories of general relativity and quantum mechanics, respectively. In 1936, Turing began to explore the universal Turing machine while studying computable numbers. In 1945, von Neumann, who joined the Manhattan Project, introduced the 3 laws to the computer field. In 1948, Shannon proposed information entropy and Shannon's theorem after discussion with von Neumann. In the early 20th century, Fields proved the Riemann-Roch theorem and dedicated himself to global mathematical communication. In 1941, Hedy Lamarr and George Antheil invented a frequency modulation technology, which was implemented in wireless communication systems. In 1965, Gordon Moore summarized practical experience and proposed Moore's Law, which has since been widely followed. In 2000, Gao Kun spearheaded the development of the world's first 1-kilometer long optical fiber network. In 1986, Geoffrey Hinton applied backpropagation to deep learning. Scientific research and technological advancement progress incrementally in this way. Link up theory with practice and aggregate resources. Make active exploration and innovation. Discuss and exchange ideas to ignite inspiration. Develop talent and the ecosystem. Chas Park website. Aggregating global high-value scientific and academic information. Offering multiple intelligent and efficient services. Connecting global academic, technical, and talent resources. Connectivity, innovation, inspiration, fusion. Chas Park website, together with you, driving global scientific and technological progress.
Good afternoon, ladies and gentlemen. Welcome to the opening ceremony of the 2026 Universal Cup Finals. I'm calling from the Universal Cup Organizing Committee, and it is my great honor to be your host today. We are very happy to gather here in Shanghai with outstanding contestants, distinguished guests from around the world. On behalf of Universal Cup, I would also like to express my sincere gratitude to Huawei for their strong support to this event. Just now, we revisited some wonderful moments from previous Universal Cup events. Throughout the year, Universal Cup has continued to contribute to the global competitive programming community. And today, we are delighted to welcome everyone to this year's finals. Now, please allow me to recognize and welcome our Universal Cup founders and distinguished guests. Please stand up and give the audience a wave. Mr. Chen Jingbang, co-founder of Universal Cup, and also the co-president of Universal Cup, chairman of Organizing Committee. Welcome. Mr. Shi Qingyu, co-founder of Universal Cup, is also the co-president of Universal Cup, chairman of Scientific Committee, and chairman of Technical Committee. Welcome. Mr. Du Yuhao, co-founder of Universal Cup. Welcome. Mr. Lü Yaowei, co-founder of Universal Cup. Welcome. Mr. Jiang Lingyu, co-founder of Universal Cup, is also Deputy Chairman of Scientific Committee. Welcome. Mr. Zeng Yaohui, co-founder of Universal Cup. Welcome. Mr. Xiao Chunpeng, Director of Contest Management Department, Huawei. Welcome. Mr. Rui Jiang, Director of Copernic Research Center, Huawei. Welcome. Ms. Chen Yong, HR Director of Shanghai Research Center, Huawei. Welcome. Mr. Liu Qingxin, MAE AI Algorithm Expert, Huawei. Welcome. Mr. Guo Chen, Principal Engineer in Wireless Network Optimization, Huawei. Welcome. Mr. Wei Zizhuang, Expert from the AI Algorithm Department, Huawei. Welcome. Ms. Li Wenxin, Coach of Peking University. Welcome. Mr. Wu Xiaojun, Coach of Tsinghua University. Welcome. Mr. Robert Xiao, Coach of University of British Columbia. Welcome. Mr. Zachary Frickstad, Coach of University of Alberta. Welcome. Mr. Richard Peng from University of Waterloo. Welcome. Mr. Wang Can, Coach of Zhejiang University. Welcome. Mr. Yang Ya, Coach of Beijing University of Post and Telecommunications. Welcome. Mr. Sun Weiwei, Coach of Fudan University. Welcome. Mr. Zhou Chenran, Coach of Nanjing University of Aeronautics and Astronautics. Welcome. Mr. Yang Peng, Coach of the University of Electronic Science and Technology of China. Welcome. Thank you all for joining the 2026 Universal Cup Finals. The Universal Cup is an organization aiming at serving the competitive programming community, dedicated to provide high-quality training resources and host on-site global events. We aim to establish a communication bridge across the industrial, academic, and competitive programming community, creating a community that goes beyond geography and age. To begin our ceremony, please join me in welcoming Mr. Shi Qingyu, co-president of Universal Cup, to deliver the opening remarks. Welcome.
Okay, thank you. Good afternoon, everyone, and welcome to the 2026 Universal Cup Finals. It is so great to see all of you here in Shanghai, gathered from every corner of the world to compete against the very best teams in competitive programming. This is the biggest on-site event we have ever hosted, with the largest group of guests, judges, and contestants qualified from the regular season. And first of all, I would like to thank every one of you for joining us on this week-long journey and for your continued support of the Universal Cup. If it is your first time at our on-site events, I hope this week becomes a wonderful memory of you. Please don't hesitate to come to talk with us, the judges, the staff, and of course, the contestants and teams. We are always excited to meet new people, make new friends, and share this experience with all together. And if you are an old friend, I hope this event brings back you very familiar memories. You know, the amazing buffets, the ping pong games, you know, video games, campus tours, our challenge session, and of course, most importantly, our finals event and our problem set. You know, we posted the call of talks last year, and we have received more than 350 task proposals from more than 20 regions. Obviously, I won't talk about the problem set in detail before the finals event, but I will show you more details in the closing ceremony. As always, we believe every one of you will have an amazing experience in the contest, and I hope you can show your talent and skills on the stage. But we do have something different this year. Something you contestants may have already heard of, and you should probably know it, is our rule changing for the AI this year. I know many of your teams have been doing the UCAP since our first season, which also happens to be when the chatbots and AIs first reached to the general public. And when we were hosting our first competition in Cancun, actually, we don't even consider the existence of the AI and chatbots because, well, they are not even close to solve the easiest tasks in competitive programming. And I think many of you have participated in our last year's event, and at that time, we have first heard some chatbots and AIs who claimed to win gold medals in some international competitions. And at that time, we found that even the strongest available models to the general client is not able to solve even the easiest task in the problem set. So we thought that AI could be a part of our competition, and we even proposed a task that AI could help you to research. And I think you all remember the moments when USA won solved that task in the first hour of the competition. And in our most recent semifinals, which is also the last of our competition, without any restrictions on a single-threaded AI, we have seen the real impact of those agents. And after reviewing the proctoring videos and feedback from our contestants, we have saw the real impact of those AIs. And what followed is the story you have all know. The online contest platforms across the board moved to restrict the use of AI, you know, from code forces to ad coder to basic everything in online competitions, like what we have did in our fourth season of the UCAP. And before the finals, the judges and the scientific committee have been struggled with whether we should preserve our tradition to have a fully unrestricted contest format. And after several debates, we ultimately decided that protecting the pure enjoyment of the contest mattered more than building a problem set that AI cannot solve anything. I think you all agree that you come here to enjoy some interesting problems in the contest, and you are not going to compete with some random AI bots with a very difficult problem set. And I know none of you here come here to hear some repeated news, you know, those AI news that has been flooding the forums and media. But we do need to take some actions to preserve our spirit of the contest and create an equitable competition environment for all of you, the fans of mind sports. Over the next days, our committees will hold several of our annual meetings to discuss plans of our next new Universal Cup, including the contest structure, qualifying criteria, our plans, and the host of our next event. And for more details about our organization plans and structures, they will be covered by Jiman's next speech. Also, these finals will also mark the end of our third season of the UCAP. And I'm sure that over the past years, you have seen many memorable tasks, contests, and moments when you are competing. And our committee has been looking for an opportunity to compile the most valuable moments from the past years of the Universal Cup. I can remember that when I was first doing the competitive programming, I was reading a nice Polish book looking for a challenge. I think some of you may have heard that, and I think I have learned many brilliant ideas from this famous Polish book. So thank you, Polish friends. And we want to do something similar. We want to cooperate with the task authors and our SC committees, and we want to compile a collection of outstanding tasks from the last season, and they could serve as a keepsake for our future events. If we are able to do so, we are going to post an announcement in our server, and we are looking for the recommendations from all of the teams so we can have a booklet in our next UCup finals. And finally, thank you all for coming to our UCup finals. I hope you can enjoy every part of the event, meet new people and make new friends, and have a fantastic experience here with us. Thanks, everyone.
Thank you, Qingyu. Next, please enjoy a video. Who is Huawei?
我们价值体系是要为人类服务。
From an independent startup to one of the world's top information and telecom technology providers, Huawei connects and serves more than 3 billion people across 170 countries and regions. Working with top minds, we're building a fully connected and intelligent world. Our tech transforms lives for the better. For industry, energy, transportation, cities, and the environment. Huawei transforms. In healthcare, education, finance, and in everyday life, Huawei transforms. We invest in fresh ideas and constant innovation. We believe in open collaboration and partnership. We care about our employees. We care about the communities we work with and live in. We care about the health of our planet and are dedicated to actively protecting it.
Thank you for watching. Now let us welcome Mr. Xiao Chunpeng, Director of the Huawei Contest Management Department, to give us a greeting. Welcome.
Distinguished guests, world-class programmers and technology leaders, good afternoon. On behalf of Huawei, it is my great honor to welcome the world's finest programming talents to Huawei's Shanghai Lianqiu Lake campus for the 2026 Universal Cup Finals. Today, we gather to witness a top event in competitive programming, where ICPC World Channels, IOI Gold medalists, and elite contestants from dozens of countries compete on the same stage. Over the past year, Huawei has continued to break new ground. According to our 2025 annual report, the company achieved steady revenue growth and R&D investment, exceeding 21.8% of total revenue, demonstrating our unwavering commitment to innovating for the future. At the forefront of technology, Huawei is leading transformative advancement. Yet the foundation of this progress is talent. In the era of digitalization and intelligence, Huawei firmly believes that people are the core of technology, and the competitions are a catalyst for talent development. To Huawei, these competitions represent far more than tests of skill. They are microcosm of collaboration, exploration, and breakthrough in innovation. What you demonstrate here, the ability to solve complex problems efficiently, rigorous algorithmic thinking, and creative brilliance under extreme pressure, represents precisely the kind of superpowers our digital future needs most. Since its inception in 2023, Universal Cup has grown into one of the most influential programming competitions worldwide, a true battleground and incubator for coding excellence. Hosting this year's finals in Shanghai, a city blending tradition and innovation, mirrors the essence of technological evolution, grounded in precise code, yet visionary in design. Huawei takes immense pride in supporting this platform because you prove that competitions are not just about winning, but about igniting technological progress. You are defining tomorrow's technology, and this arena is a proving ground for the future. When you optimize passes with dynamic programming, you may inspire next-gen decision-making algorithms. When you solve problems with graph neural networks, you could accelerate AI-driven drug discoveries. When you debate concurrent programming with rivals, you might plant the seeds for tomorrow's distributed systems. Huawei stands with you as a partner. Through tools like Huawei Cloud AI and Mandelsport, we lower barriers to innovation. Platforms like the Huawei Challenge bridge elite code with real-world applications. We keep supporting global talent development. Supporting competitions like U-Cup nurtures a community of over 50,000 plus programmers. We advance algorithms and fundamental research because today's contest problems could become tomorrow's world-changing breakthroughs. We hope all the contestants can compete with passion and live with inspiration. May your code flow like the Huangpu River and your ideas shine like the Oriental Pearl Tower. Let's make the 2026 Universal Cup Finals an unforgettable milestone. Thank you very much. Thank you.
Thank you, Mr. Xiao. Now let us welcome our contestant representative, Mr. Jae-Hin Koo from Team Ngongong to share a few words with us. Welcome.
Hello, everyone. My name is Jae-Hyun Koo, better known as Kusaga in competitive programming. I'm a PhD student in MIT and also an ICPC coach in MIT, studying theoretical computer science. But today, I'm here as a contestant in Universal Cup Finals. For a programming contest community, Universal Cup is a very special event, and as it is the largest team contest that is open to everyone. It is also special in a way that the contest is largely organized by community members who understand from the community perspective. So this is the first time I have ever participated in Universal Cup Finals, but I guess I can already say this. I attended a lot of corporate organized programming contests in the past times, like Google CodeJam or like Facebook Hacker Cup. But I think I never had a contest that is this big and also this well organized. So I've already spent a pretty good time in the hotel that is provided by the organizers, and I'm looking forward to all the event waiting us. And also, I appreciate all the organizers and Huawei for preparing and sponsoring the event. So I have been doing programming contests for about like 13 years already, and this is an important pursuit for me. And I can say that I wouldn't have tried to pursue PhD studies or whatever if I did not participate in programming contests. So basically, I made a life choice based on programming contests. And so you can ask, why does it matter that much to me? I think this is fun for everyone here, and that's quite important, but also, I guess that's obvious if you're here, I guess, so I won't bring that up. I believe even with all the recent technological developments, there are some timeless aspects in problem solving, and there is value in creating and discovering new paths for short and natural problems in computation. So the world is rapidly changing, but I believe in timeless values. I hope this Universal Cup Finals could be an opportunity for everyone to find such a thing. I hope everyone to enjoy more data structures in their life, and thank you.
Thank you, Jae-hyun. Next, please join me in welcoming Mr. Chen Jingbang, co-president of Universal Cup, to give us opening remarks. Welcome.
Hello. Okay, so let's do something that I already did last year. So, welcome, 欢迎, 欢迎, Yokoso, Dobro pozdravovat, Laskavo prosmio, Witamet, Hongan Yan Hamida, and welcome again to the 2026 Universal Cup Finals. Many thanks to President Qingyu and Mr. Xiao and Ko-Osaka for their wonderful speeches. Today, for Universal Cup, it's both a reunion and an assembly, because 1 year later, 23 of the very best teams in the world have gathered here in Shanghai. Once again, we welcome many old friends who have walked into this role with us since the beginning, and we also welcome more outstanding contestants and distinguished guests who have been invited here for the first time. The reunion of friends tells us that this journey has not been in vain, and the gathering of so many remarkable people tells us that Universal Cup is drawing broader and broader attention, recognition, and support. Every friend here today is a witness to that recognition. And after 3.5 years of effort, we finally are no longer merely looking up at the stars and holding up onto a dream, but we have truly brought together a group of remarkable people and forged them into a growing force, one that is working together to open a new chapter for the competitive programming community in this new era. First of all, I would like to especially thank our partner, Huawei, for its tremendous support. Without you, none of this would have been possible. Thank you very much. So people have been asking, and I have been returning again and again to one question. What exactly is Universal Cup, and what is our mission? As we stand here today, we have already built a high-level, high-frequency system of online training contests that runs throughout the year. And we have already successfully held 2 on-site events, and I hope this is the 3rd one. But I have always felt that this is still not the whole of Universal Cup. After many rounds of discussion with our wonderful organizing committee, one conviction has been clear to us. If all we do is providing training resources and organizing contests, then Universal Cup is still far from where it ought to go. What we truly want is to help lead this entire community towards a new shape, a new structure, and a new future. Over the past year, we have, for the 3rd consecutive year, helped ensure the smooth running of the Huawei LAC Challenge. We were invited on site to provide full technical support and to introduce Universal Cup to contestants and coaches from Latin America. We have also launched a public lecture initiative, visiting universities and communities that wanted support, and sharing our thoughts on contest experience, training systems, and paths of growth. Not long ago, so two of our staff, Wang Junyao and Tan Jie, gave a talk at Nanjing Xiaozhuang University. The students there achieved a breakthrough soon in the contest later that concluded just last week, and were excited to share the good news to us and also their gratitude to us. We also held our first online marathon event, and we are already preparing for more activities that will connect more deeply with industry. All of this has made me believe even more strongly than what Universal Cup seeks to do is far more than simply gather resources together. What we want to build bridges across industry, academia, and the competitive programming community, and to help shape a community that transcends geography and age, and truly belongs to this new era. It may sound a bit ironic, but I have always described myself as a radical conservative. As I said last year, even today, I still believe that continuity and survival remain the most fundamental priority of the Universal Cup. But over the past year, the people who have gathered around us and everything that has unfolded have led me to understand something more deeply. So very often, the more you want to hold your ground, the less you can afford is to stand still and not move forward. Because the world is moving forward. The talented people are moving forward. The needs and imagination of the whole community are also moving forward. You must move with that momentum, and you must also bear the pressure that comes with it if you truly want to carry Universal Cup and the community forward. And for exactly this reason, over the past year, we have continued to bring in more people who are ambitious, capable, and genuinely willing to devote themselves into the community. And we have begun to push forward organization reform. Taking the opportunity of these finals, we will also hold a series of meetings to further review, refine, and improve our organizational structure. So after last year's finals, we established two teams, the challenge team and the live team. So by now, both have already begun to show their value. The work of the challenge team speaks for itself, while the live team, led by Dai Longhao, have already produced a series of innovations and new initiatives. In the next few days, you will see the changes these efforts have brought to our live broadcast. So turning to the finals itself, and building on what we learned from last year, we have made many new attempts this year, so we have arranged an academic talk focused on the impact of AI on competitive programming, in the hope that all of us can discuss together the changes this era is bringing. We also have designed more ice-breaking activities, hoping that contestants can break through the barrier of language and team boundaries, and have the courage to reach out and begin the new conversations with everybody around you. We also want every team that has come here and to feel truly seen and sincerely welcomed. That is why Qingyu and I wrote a personalized welcome letter for each team separately. And I believe you have already received them by now. So there are many other efforts like this. So we are not doing them to make things more complicated, but because we want all of you to truly enjoy this grand gathering that belongs to all who love competitive programming. By the way, I took these pictures. So finally, I would like to say this. Holding an on-site finals is certainly something to be proud of, but Universal Cup will never treat this moment as an endpoint. Reaching this point only means that we have arrived at a new beginning, and there is still much more for us to accomplish. And there are still greater goals for us to pursue. We sincerely welcome more people to take part, to join us, more forms of collaboration, and all well-intentioned, candid opinions, suggestions, and even criticism are all welcome. A truly vibrant community is not closed, not self-satisfied, and not trapped with the experience of the past. It grows through exchange, becomes stronger through collaboration, and keeps finding new directions through changes. Our era is moving forward at an unprecedented pace, and we are willing to embrace that change together with everyone here, and to carry Universal Cup together into a brighter future. Once again, thank you all for your support. I wish everyone a wonderful time here and the very best of luck in the 2026 Universal Cup Final. 谢谢.
Thank you, Jingbang. Now it is time to introduce the finalists of the 2026 Universal Cup Finals. May I invite our co-founders, Mr. Chen Jingbang, Shi Qingyu, Du Yuhao, Lü Yaowei, Jiang Lingyu, Zeng Yaohui to stay on stage, and they will introduce our finalist teams. Welcome. Please stand up and wave your hands when your name is announced.
Okay. So, USA 1, Andrew He, Kevin Sun, Gennady Krotkevich, please stand up. Homama OEO, Riku Kawasaki, Masaki Nishimoto, Yui Hosaka. Okay, my biggest challenge. Polish Mafia, Wojciech Nadara, Matusz Radecki, Maciej Smolewicz. Welcome. Transcend Light, 许其文、陈诺、何凡佑。
Okay, so the next team is a team Lumina from Peking University, and they are Zhu Yikai, Chen Xinyang, Shen Jiyu. And next is the team Yusupov. They are Kohi Morita, Takuto Shigumura, and Shogun Murai. And the next is the team Flammable Dumpster. They are Wu Lin, Zhu Pengrui, Li Qingyang. And next is the team Thinking. They are Fyodor Rumashov, Alexei Miknikov, and sorry, and Gibran Abdulin. Sorry.
Okay. Wait. Okay, let me introduce. This team is Japan 406364961. Okay, the member is Ryu Takahashi, Masanori Ogiwara, and Takuto Koriyama. Welcome. Our next team is the Arvin and the Arrow Game. The members are Yuto Watanabe, Yui Arvin Liang, and Ashley Aragon Ku. Welcome. The next team is Tono-sama. The team members are Tatsuhito Yamagata, Yasunori Kinoshita, and Kosuke Kaneshita. Welcome. The next team is almost retired Dandelion. The team members are Yahor Dobovic, Oleg Mirkulev, Alexei Daniluk. Welcome.
And the next team is We Play With Mud in the Northeast, Stanley Wei, 程泽瑞、何中天. Welcome. And it's the one-person team again. Freak Plus, Liu Hengxi. Welcome. And the next team is the Void Protivatra, Igor Kulikov, Pavel Mavlin, Boris Minaev. Welcome. And Afterlife, Peng Bo, Yan Zixuan, Zhang Qiuyang. Welcome.
The last team is Polar Bear Transform, Maxim Tulevsky, Fodor Usakov, and Leonid Danilevich. Welcome. The last team is when Andong saw this team, he reacted with an emoji. Andong Tritu, Taven Ustalu, Alexander Kurkov. Welcome. The last team is Absolute Advantage, Zhou Boyu, Zheng Xianyang, and Brian Cai. Welcome. The last team is Wen Gongzhan, Sangyang Zhe, Zhe Yan Ku, and Minqiang Zheng. Welcome.
Okay, so Yao Hui is still on his way to here, but because there's a weather change towards the flight delay, so I will take his part. So Amstel Park, Mikhail Ipatov, Pavel Kamyansky, and Artem Vasilyev. Welcome. And Captain Take Me Not, Fang Xintong, Zheng Jun, Jiang Chengyou. Welcome. And the last team, Bad at DS, Fan Shizhe, Shi Haojia, Wang Xianbang. Welcome. So these are all the teams that will compete in the 2026 Universal Cup Finals. We wish them the best luck.
Congratulations to all our finalist teams. That give us another big round of applause. Welcome, our team. Co-founders, please remain on the stage for the ceremony. And now we come to the official launch of the 2026 Universal Cup Finals. Now let us invite Qingyu to lead the launch moment. Please give us just a moment while we prepare the stage.
Okay, so here I announce that the 2026 Universal Cup Finals is officially launched. 3, 2, 1.
Congratulations and thank you. Please be seated. In the next parts of the program, we will have a short break of 10 minutes and followed by another Huawei talent video and a Huawei Keynote session. Please don't leave the venue, and the group photo is after the Keynote session. Thank you.
Is progress in science and technology. technology come from? From insights gained through practices. From sparks of discovery. From inspiration sparked by the clash of ideas. From elevation achieved through the fusion of different perspectives. In 1654, Pascal and Fermat opened the door to probability theory in their discussion on the problem of points. In 1687, Halley persuaded the hesitant Newton to write his great work, Mathematical Principles of Natural Philosophy. In 1736, Euler attempted to solve the puzzle of the 7 bridges of Königsberg, which led to the creation of graph theory. In the early 20th century, Einstein and Bohr collaborated and completed to develop the theories of general relativity and quantum mechanics, respectively. In 1936, Turing began to explore the universal Turing machine while studying computable numbers. In 1945, von Neumann, who joined the Manhattan Project, introduced the 3 laws to the computer field. In 1948, Shannon proposed information entropy and Shannon's theorem after discussion with von Neumann. In the early 20th century, Fields proved the Riemann-Roch theorem and dedicated himself to global mathematical communication. In 1941, Hedy Lamarr and George Antheil invented a frequency modulation technology, which was implemented in wireless communication systems. In 1965, Gordon Moore summarized practical experience and proposed Moore's Law, which has since been widely followed. In 2000, Gao Kun spearheaded the development of the world's first 1-kilometer long optical fiber network. In 1986, Geoffrey Hinton applied back propagation to deep learning. Scientific research and technological advancement progress incrementally in this way. Link up theory with practice and aggregate resources. Make active exploration and innovation. Discuss and exchange ideas to ignite inspiration. Develop talent and the ecosystem. Chas Park website. Aggregating global high-value scientific and academic information. Offering multiple intelligent and efficient services. Connecting global academic, technical, and talent resources. Connectivity, innovation, inspiration, fusion. Chas Park website, together with you, driving global scientific and technological progress. Where does progress in science and technology come from? From insights gained through practices. From sparks of discovery. From inspiration sparked by the clash of ideas. From elevation achieved through the fusion of different perspectives. In 1654, Pascal and Fermat opened the door to probability theory in their discussion on the problem of points. In 1687, Halley persuaded the hesitant Newton to write his great work, Mathematical Principles of Natural Philosophy. In 1736, Euler attempted to solve the puzzle of the 7 bridges of Königsberg, which led to the creation of graph theory. In the early 20th century, Einstein and Bohr collaborated and completed to develop the theories of general relativity and quantum mechanics, respectively. In 1936, Turing began to explore the universal Turing machine while studying computable numbers. In 1945, von Neumann, who joined the Manhattan Project, introduced the three laws to the computer field. In 1948, Shannon proposed information entropy and Shannon's theorem after discussion with von Neumann. In the early 20th century, Fields proved the Riemann-Roch theorem and dedicated himself to global mathematical communication. In 1941, Hedy Lamarr and George Amthel invented a frequency modulation technology, which was implemented in wireless communication systems. In 1965, Gordon Moore summarized practical experience and proposed Moore's Law, which has since been widely followed. In 2000, Gao Kun spearheaded the development of the world's first 1 kilometer long optical fiber network. In 1986, Geoffrey Hinton applied back propagation to deep learning. Scientific research and technological advancement progress incrementally in this way. Link up theory with practice and aggregate resources. Make active exploration and innovation. Discuss and exchange ideas to ignite inspiration. Develop talent and the ecosystem. Chas Park website. Aggregating global high-value scientific and academic information. Offering multiple intelligent and efficient services. Connecting global academic, technical, and talent resources. Connectivity, innovation, inspiration, fusion. Chas Park website, together with you. Driving global scientific and technological progress. Where does progress in science and technology come from? From insights gained through practices. From sparks of discovery. From inspiration sparked by the clash of ideas. From elevation achieved through the fusion of different perspectives. In 1654, Pascal and Fermat opened the door to probability theory in their discussion on the problem of points. In 1687, Halley persuaded the hesitant Newton to write his great work, Mathematical Principles of Natural Philosophy. In 1736, Euler attempted to solve the puzzle of the 7 bridges of Königsberg, which led to the creation of graph theory. In the early 20th century, Einstein and Bohr collaborated and completed to develop the theories of general relativity and quantum mechanics, respectively. In 1936, Turing began to explore the universal Turing machine while studying computable numbers. In 1945, von Neumann, who joined the Manhattan Project, introduced the 3 laws to the computer field.
So we are about to start next session. Please be seated.
Information entropy and Shannon's theorem after discussion with von Neumann. In the early 20th century, Fields proved the Riemann-Roch theorem and dedicated himself to global mathematical communication. In 1941, Hedy Lamarr and George
So,
Enfield.
hi everyone. We are going to begin next session. Please be seated. Thank you.
In wireless communication systems. In 1965, Gordon Moore summarized practical experience and proposed Moore's Law, which has since been widely followed. In 2000, Gao Kun spearheaded the development of the world's first 1 kilometer long optical fiber network. In 1986, Geoffrey Hinton applied backpropagation to deep learning.
We are about to start. Please be seated. 下一个活动即将开始，请大家有序就座。
Link up theory with practice and aggregate resources. Make active exploration and innovation. Discuss and exchange ideas to ignite inspiration. Develop talent and the ecosystem. Chas Park website. Aggregating global high-value scientific and academic information. Offering multiple intelligent and efficient services. Connecting global academic, technical, and talent resources. Connectivity, innovation, inspiration, fusion. Chaspark website, together with you. Driving global scientific and technological progress.
Thank you. Now let us welcome Dr. Tian Kun to give the keynote speech. Agentic AI reshaping AI software hardware infrastructure. Welcome.
Hello everyone, and congratulations to all of you who made to the Universal Cup finalist, and welcome to Huawei Qingpu campus. My name is Kun Tian, and I'm from the computing product line of Huawei, working on AI infra optimization right now. It's a great honor to give the keynote speech today, and I figured that probably most of you are from Gen Z, so I'm gonna make today's keynote more or less a casual conversation where we can talk about anything about AI infra or agentic AI or anything you're curious about the computing product line at Huawei. So for today's keynote, I prepared two questions. The first one that for most of you probably that you're an expert or genius at a certain field like mathematics or computer science, but you may wonder that how you can combine your expertise with the field of computation. So for that, this is kind of far away. See. So I'm gonna give you like an angle how to dive into this field. If you're not interested in this one, then maybe you wonder about like what are the challenges we're facing nowadays by the current computer systems in the age of agentic AI. And that's the second topic we can talk about a little bit. So my background is actually in computational neuroscience, which is like a cross domain between AI and neuroscience. Now in that field, we basically use mice or computer science to model everything we can find from the biological system. So just to give you an example of a Nobel Prize winner from 1963, where they basically modeled what we call a cell membrane current flow. Because for a typical cell, we know that there are all types of membrane channels like sodium, potassium, and leaky currents. What they did is that they abstract this membrane current into a electric circuit, and using a bunch of ODEs to model how the current flows with a bunch of activation and deactivation parameters. And they did this before they actually did experiments. And the experiments actually match perfectly or elegantly to what they have modeled or simulated, and they won the Nobel Prize for this work. So from my background, everything can be modeled or abstracted given enough assumptions or constraints. Now, given that perspective, when we come to the computation systems, we can see that it basically composes of two components. First one is the backbone. The backbone, basically a bunch of building blocks, meaning they're CPUs or NPUs or, let's see, okay, CPUs, NPUs, GPUs, or AI NICs. And they're connected by a bunch of links that whether they're in the scalp domain or the scale domain. And the difference between the scalp domain and scale domain is like the difference between like a highway speed or a country road, where for components or building blocks that need high bandwidth for communication or data transfer, we put them in the scalp domain. And for those that are not, we put them in the scale or country road. And this is basically composes the backbone or the static structure of a computer system. And on top of that, we have all the AI workloads that determines how the information flows in the system. And for modern LM age, we have all types of models that each have different requirements or characteristics. To give you a few examples, for like multimodal generation, like video generation models, they require high computing power and communication bandwidth. And for typical text generation or multimodal understanding models, then they have like a very complex requirements, both containing computing power and communication bandwidth during the prefab stage, and the memory bandwidth and the communication latency during the decode stage. So basically for the whole system or the whole area, what we're trying to figure out is how to map this all kinds of workload to the computer systems for the best efficiency or best tokens per flops. Now to further break what does AI workload mean in this field, we basically divide them into three categories. So a typical workload composes of both the model and the system optimization strategies and the traffic model. So for the model, basically, it's all the classical model architecture or structure, like the attention type, or whether it's dense or sparse FFN. And also the model size, whether it's terabyte or gigabyte, and the learning paradigm, whether it's autographic or diffusion. And also the system optimization can affect how we design the building blocks of the computer systems, like whether we deploy them in a single system or put the prefill decoding to separate systems. And also all kinds of software optimizations like quantization, parallel strategy, scheduling strategy, they can all, including speculative decoding strategies, they can all affect how we build the system. And on top of that, when it comes to application, the context length or the time requirements from the system can also affect how the system looks. So this is a typical AI workload for a computer system. And when we map to the computer systems, they can all map to different levels of the system. At the very top is the application layers, where basically we care about the coordination between models and all kinds of other tools and their interactions. Typical examples are like agentic RL or agentic AI inference. And in the middle, we have this model layer where basically it composes of all the operators and their control flow. Typical examples are like DeepSeek models or a Llama model. And then we break the model into their basic units, which are the operators, like a typical gem or transpose operator. And this is usually mapped to the microarchitecture of a chip. And at the bottom, we have these instructions who are mapped to the microarchitecture of a chip, like matrix multiplication instruction. So when we further quantify the AI workload and see how it affects the system, then we can see that basically for the AI workload, we have this basic model structure nowadays, which is a transformer, where it composes of all the transformer layers. Each layer composes a attention module and the FFN module. And then we have this input where it basically determines by their context length, their hidden dimension, and their byte size. So basically, all those parameters determines how their requirements for the compute, memory, and the communication for the system. And then when we list all the requirements for different life cycles, like for the training or the inference stage, and with different learning paradigms like autoregressive or diffusion, we see that they each have different requirements, but basically the most influential factors are the learning paradigm, the context length, and the batch size. So for example, like for the context length, we see that the computational requirement for the prefill stage grows quadratically with the length, and the memory requirement grows linearly with the length. And for batch size, we see that both the computational and memory requirement grows linearly with the batch size. And when it comes to learning paradigms, it becomes a little bit more complicated because the learning paradigms need to be put in the context of this deep learning paradigms, where we see that they basically inherit what we derived from the deep learning stage, where you have a general task description where you want to minimize the evaluation loss for a certain task, given the training objective, and both the training data and the evaluation data are coming from the same distribution. Given this whole general description, or we can also divide learning paradigms by different ways. For example, if by learning objectives, then we have supervised learning where you have the labels, and unsupervised learning where you need to learn the label from their distribution. And by models, we have parametric models and non-parametric models, and also what we use nowadays neural networks were containing CNN, RN, and transformer. And for the first two, probably some of you never heard of because they're kind of like a pre-deep learning stage methods. And by task structure, then we can optimize for a single or multi objectives, or we can optimize for transfer learning or online learning or meta learning. And for larger language models nowadays, their learning paradigms basically come from the unsupervised learning branch. And for this branch, we further see there are different types of learning paradigms. And the generative model ones are basically learning whether you're learning a probabilistic distribution matrix or a denoising objective, which are the foundation for modern large language models. For example, for the autoregressive ones, where you generate a token one by one, and the previous and the next token depends on all the previous context or equivalence. And this is actually a classification problem that, given the universal approximation capability of modern transformers, we can basically approximate any type of distributions in this scenario. And for image or video generation, nowadays we're basically using a denoising objectives where we inject noise to the pictures or the videos and learn how to remove them step by step. So together, if we see that with all the learning paradigms, the context length difference, the different batch sizes, and different model architectures, then the AI workload, they diverge enough that we can never fit all of the models or all of the requirements into a single chip or single system design. So with that, we see that for the past few years, every time the field publish a new model with a new learning paradigm or a new architecture, or we see that the inference system change with the model with a co-design, co-evolved way. For example, at the very beginning, about like 2 years ago, Kimi first published their first million token sequence model, where this model kind of derives when we have a PD disaggregation kind of deployment strategy nowadays, where prefer decode into different clusters. And later, when OpenAI published their Sora, a video generation model, we see that this model requires lots of computing power and lots of communication bandwidth, but not very sensitive to memory bandwidth or communication latency. And this one requires a specific chip called CPX, or with like high IP4 power but low memory bandwidth. Later, we have this full model understanding where we have both the prefill and decode stage, and they need to separate into. They still require the same PD disaggregation kind of deployment strategy. And then we move on to the end of 2024, where we see the publication of 01 and 03. Those models, they generate lots of tokens, which requires lots of memory bandwidth and communication latency, but also memory capacity. So at this stage, we see that there is more demands for different types of memory or storage medium, and we need to separate the storage from the compute to further boost the compute efficiency. So at this stage, we see that there are some separations between compute and storage, or put DRAM or SSD into a different cluster. And nowadays, we move to the agentic AI area, where we see that it's not a single model, but a composite of different models, all with different requirements. And at this stage, we're still exploring and also optimizing try to figure out what the best system for it. But in general, it looks like we need to integrate both the CPU, NPU, and memory storage into a scale-up domain for a flexible kind of ratio. Like we're manipulating to put their memory cache. So to further, so we actually figure lots of requirement challenges for agentic AI, but today I'll just give you 2 of them. First one is about the data movement between different memory medium. We see that with the model going from a dense model to a sparse model, each model's per token activation drops, but the model weight increases. So in general, we demands more capacity but less bandwidth for each token. Now in the agentic AI stage, where we see that the context length grows from thousands to like million tokens. And then in that stage, like we require more and more capacity for putting the KV cache, but also with like sparse activation or linear or compression, all kinds of techniques, the single token activation drops down. So this further pushed this trend to more capacity and less bandwidth, sometimes even going beyond this HBM's field into DDR or SSD's range. So nowadays, like during this NVIDIA's GTC 2026, we see that they also talk about this trend and classify the AI memory into 4 stages, where you have the first one containing all the high bandwidth memories in the NPU or GPU, and the second stage where you have all the system DRAM, and the third one containing all the local storage, and the first one is the shared remote storage. For this hierarchy, when you're going from the top to the bottom, then we have more and more capacity, but also slower data transfer capability. That means we need more and more time to transfer data between them. So in general, we see that the system demands more storage or capacity, and we also need to keep them under a certain time limit. Now the bottleneck for this agentic AI period is moving from the compute to the efficiency of moving data among GPU, memory, and storage. So just to give an example of what do we mean for the bottleneck. So first we see that when you have this sequence going to like 1 million tokens, and you need to store them for reusing for the next turn interaction, then when you have to save all the KV cache at some places. And HBM doesn't have enough space for all of them, so you need to put them into whether the DDR or further put them into a remote SSD storage space. And then we see that given nowadays agentic AI's capabilities, first, they have very high cache hit rate, where every time you can probably reuse like 90 or 95% of what you previously generated. And this requires a high bandwidth to transfer them all back to the GPU. Now we also see that for the bandwidth requirement, when the cache hit rate goes from 70% to 99%, the bandwidth requirement also grows. The second change is that previous days when we have like chatbot, then we just have like a short conversation with the bot and it ends. So it barely saves any of your chat history. But nowadays, a typical task can last from minutes to hours to days. So they need to save all your previous state or cache for to complete the whole task. And now, different agents or models, they have different strategies. For example, for Cloud Code, like they allow you to save either for 5 minutes or hour. And for DeepSeek Wave 4, you can save for hours or days. That means like we need a storage medium where we can put what we have generated before in there for hours to days. And this requires a totally different memory hierarchy here compared to what we have here, which is a local SSD, where it doesn't have, which cannot be shared between different peripheral nodes. A second requirement comes from decode cache. So when you go to the decode stage, because the sequence length also increases from 2 million tokens, and they also can hit the memory capacity bound of HBM. And at that stage, our first choice is to offload all the cache to the system CPU, just connect to each NPU. And if that's not enough, then we need to figure out whether a new medium with more capacity but also high bandwidth, or change the CPU-GPU ratio so each CPU-GPU have higher bandwidth and more capacity, or expand the DDR server through a bus protocol to further satisfy the bandwidth memory needs for this scenario. So the second challenge comes from this bubbles in the system. So previous days when we have a typical LM inference, it contains two stages, which is the prefill and the decode. And with all kinds of system optimization strategies, we can make sure that the general flops utilization is about like 90% for the whole system. But nowadays, for agentic AI systems, we see that between the computation of prefill and decode, there is a lot of interaction with CPUs for two execution or KV cache swap or other jobs that the system just need to wait for the job to complete before they can do the next step. And this introduces a lot of bubbles in the system and low system compute efficiency. For example, we see that for a typical agentic loop, where from the first planning stage to next replanning stage, in the middle you have two call generation and the transfer between network, and then the two execution return their result. Then we need to kind of process the result and recombine them into a prompt for next turn. So during this stage, we see that, for example, this network dispatch, the delay can range between 10 milliseconds to 2 seconds. During this stage, the NPU right now is totally idle. And also for to execution or KV carrier swap, then where they can last between millisecond to second. And during this stage, because they're a serial kind of task, then we need to wait for them to complete before we can actually do the next computation. So all kinds of these bubbles make the system utilization efficiency very low. And we need to figure out new ways to kind of overlap or hide those bubbles. So in the end, to connect all the dots, just want to show you that now we have this new agentic AI workload where it's a whole system with a bunch of interactions with both CPUs to execution and with all the memory systems for KV carrier swap. And this all introduces bubbles and also new memory hierarchy needs. And then we have these building blocks where we still have all the CPUs and NPUs, GPUs, and DPUs can either connect by a scale-up domain or a scale domain. Our problem now is that how to map this hierarchical memory need of the agentic AI system to the building blocks here so we can maximum the system throughput across the whole latency span, whether it's 1 millisecond TBOT per user or 100 millisecond TBOT per user. With that, thanks for listening, and hope you the best luck with your competition. Thank you.
Thank you, Dr. Tian, for your impressive talk. So now it's a question time. Is there any questions for the talk or any other question to the Dr. Tian? Okay. Yeah, so we have some gifts for the questions. Okay, so if not, then let's thank Dr. Tian again. Yeah, thank you. Sorry. So next we're gonna proceed with a group photo and then the garden party outside area. So during the garden party, we will take team photos. Please follow the volunteers guide. And thank you all for joining us, and please enjoy the rest of the event. Thank you. Now please move to the area by the lake. We take the group photo. Thank you.